Okay, well, it's time to start. So welcome everyone to this webinar on current and future challenges in rural road asset management. My name is Christer Palo, I'm from Sweden. I work for the Swedish Transport Administration, where I work in the maintenance department in a strategy unit. I will be your moderator today and guide you through these sessions. And I've been involved in ROADEX cooperation since 2002, and I work as a chairman also for the ROADEX network. This webinar should have been held in the Transport Research Arena 2020 in Helsinki in April, but as you all know, it was cancelled due to this COVID-19 virus, and this webinar was set up instead. I hope that the technique gods are with us today and everything will work smoothly, that won't be any problems along the way. If we will keep the schedule, we can have a couple of questions after each presentation. We will see if everything works as planned. This webinar will be recorded. And remember, keep your microphone shut if you don't intend to use it. And once again, welcome and enjoy. So to the first presentation, Mr. Ron Munro from Scotland. He will talk about the ROADEX project, over 20 years of research and implementation of new knowledge in rural road asset management. Ron is a civil engineer with over 40 years of experience in the design, construction, and maintenance of public roads in the Scottish Highlands. He has been involved with the EU Northern Periphery ROADEX projects since the start in 1998, and as a member of the steering committee and as a chairman. Now working for road scanners, he's especially involved in road construction over peat and tire pressure control of heavy vehicles. He's currently a contributor of to the ROADEX Network Secretariat. So, Ron, the floor is yours.
Okay, Christer, thanks for that introduction. I will see if I can get the Can you see my screen? Can you see my screen?
Yes. Yes.
Excellent. I'm happy at that, Rob. Well, good afternoon, everyone, from a drizzly and overcast northern Scotland. This first presentation will be a brief introduction to the ROADEX network to set the scene for the main seminar. It'll touch on some of the events on how ROADEX came about and what has been done along the way. By its nature, it'll be fairly light. The main technical aspects will be presented within the main part of the webinar by the other speakers. Are you still seeing my presentation?
Yes, it works.
Good, excellent. ROADEX started off in 1998 as a pilot project under the EU Northern Periphery programme that was set up to encourage cross-border sharing between European states. ROADEX was defined as a transnational collaboration of roads organisations to share best practice, research and develop new knowledge, implement and test new solutions. It's now been running for 22 years. Up until 2012, it was part funded by the Northern Periphery programme, and now it is funded wholly by the partners themselves. Currently, there are 13 partners in the network, as shown here. The partners pay their own costs and pay a share of the cost of the secretariat. Road scanners are the current project secretariat after an open competition. This slide briefly summarises how the network operates. All partners are entitled to a place on the project steering committee. This committee supplies the governance for the project and makes the high-level decisions. The day-to-day running of the project is delegated to the Secretariat, who manages the website and knowledge centre, runs the consultancy, arranges the demonstrations, encourages the dissemination, keeps the e-learning lessons up to date, and commissions any new research. But why do the partners collaborate, and why ROADEX? Well, to put it simply, it's in their own interest to do so. They all have common problems with reducing budgets, increasing road user expectations, increasing truck and traffic sizes and weights, and they are all looking for environmentally sustainable solutions. In other words, they need more from less. The pilot ROADEX project in 1998 proved that a collaboration across countries could work and created a network despite the obvious differences in languages, currencies, and organizations. It tested collaboration on winter maintenance and road condition management. The winter maintenance collaboration proved difficult. Winter conditions across the areas were just too varied to productively share information. Road condition management, on the other hand, immediately showed benefits and convinced the partners to do more. The pilot project identified 5 common problems across the countries, and these still form the foundation for all ROADEX considerations today. Road drainage, #1 problem everywhere. Heavy trucks and permanent deformation, poor quality road materials, roads on peat and widened roads. These problems are still common across the ROADEX area from Lapland to Ireland. This slide shows the challenge faced by every road organisation: how to deal with the growing expectations of modern production and logistics chains in times of reducing budgets. The bottom line shows the 3 options open to the manager: apply road or traffic restrictions, carry out rehabilitations, or do nothing and blame the politicians. ROADEX takes the proactive middle course, maintenance and rehabilitation measures. The ROADEX philosophy can be simply stated as focus, focus, focus. Use precise survey to map the weak sections of road and focus in on them. Focus on understanding the underlying reasons for the problems on the road. Innovate and design fit-for-purpose structures and treatments for the weak sections of road. Look at the timing of any work. Not everything needs to be fixed at once, apart from the drainage. And make sure there is follow-up maintenance after the work. The weakest sections on a road define the route in the eyes of the road user. Focus on these and road maintenance for the best use of your available resources. ROADEX recommends a detailed survey to understand what's happening in and under the road. Video, drainage, GPR, falling weight, and many others, all collected digitally to GPS to permit repeatability and to be able to identify any trends over time so that early proactive action can be taken. The data can then be processed together using modern techniques and cloud storage for use across organizations, both in-house and on-site. Results can be output in many ways: maps, models, animations, depending on the outputs to be shown and what the end user wants. ROADEX disseminates its results as widely as possible. Webinars like today, seminars, workshops, face-to-face meetings, and more recently through social media such as Facebook and Twitter. The ROADEX website, www.roadex.org, is the heart of ROADEX dissemination strategy and is a live site. Everything that's been done in ROADEX is on this website, and we're making real efforts to keep it current with new developments, as you will hear today. The key part of the website is the Knowledge Centre. All of the ROADEX information in one place, projects, reports, case studies, research, all accessible and all free of charge. The website holds the 4 ROADEX e-learning lessons on permanent deformation, roads on peat, drainage of roads, and environmental considerations for roads. More on these later. The lessons have received excellent reviews since they were released and are now actually being used as self-learning undergraduate training packages in some universities. They're being brought up to date as we speak. ROADEX tests its technologies in demonstration projects. Typically, these have been in drainage maintenance, road-friendly vehicles and central tyre inflation, forest road policies, road design, roads on peat, driver health and vibration. ROADEX has also carried out research projects, adaptation measures to meet climate change, best practice in road widening, and more research into the effects of vehicle and human vibration. Again, the results are on the website. In summary, ROADEX promotes survey methods and analysis techniques, changing the traditional visual inspection methods to modern road speed machine surveys referenced to GPS and outputting the results in easy to understand visualizations. The importance of correctly functioning drainage. This is all too often forgotten under daily pressures and budget constraints. Getting the drainage correct will always be a primary aim in ROADEX. New materials and testing methods. ROADEX has carried out really good work with new materials, additives, and new testing methods, all on the website. Design methods against permanent deformation. These are new design philosophies especially suited to low volume roads based on ROADEX research. And road-friendly trucks and tyre pressure control and investigating tyre-road interactions. That was the introduction. Thank you very much for your attention. I'll be happy to take any questions if you have any.
Yeah, thank you, Ron. Are there any questions from the audience? No questions? Okay, Ron, I have one question for you. I mean, 22 years is a long time. What is the key to keep up long-lasting international cooperation? What's your feeling?
It's a good question. Well, apart from the really good people we've got in the project and the hard work that's been done by people like Timo, I think one of the things is we have a very good relationship together. And once we've done the hard work during the day, we can come together in an evening in a hotel bedroom with a good bottle of Scotch whiskey. And that holds us together also.
Okay, yeah, it seems to be important. Thank you, Ron. Okay, let's go to this next presentation. Mr. Olli Mourujärvi from Finland. He will tell us about the PECCO project, implementing ROADEX results in Finland. Olli has a Master of Science and he works at the as a head of a unit at the Center of Economics Development, Transport and Environment for Lapland, so the so-called ELI Center. He has been a member of the ROADEX Network Steering Committee since 2018. Lapland Ely Center, and before that, Lapland Road District have been involved in the ROADEX projects since the first one started. Mr. Mourojärvi has led the PEHKO project in Lapland area since the beginning of this year. So please, Olli, you can start your presentation.
Okay, thank you, Krister. Good afternoon from Rovaniemi, northern Finland, Lapland region. A few years ago, the condition of the paved roads in Finland was getting worse, as the diagram shows. The main roads were still in quite a good condition, but the lower traffic volume roads were deteriorating rapidly. This was because the financing was not sufficient, and the national strategy was to keep at least the main road network in good enough shape. So it kind of became a low traffic volume roads problem. At that time, it was calculated that on average there was 2.25 euros per meter per year available for pavement repairs. This is like a children's pocket money for pavement maintenance. If average theoretical calculated annual cost of deterioration is more than this pocket money, it means that backlog or repair cost is gained. So, because more financing was not in sight, new kind of thinking and practices were needed to get more with less. On the bottom of the slide, you can see one of ROADEX publications, ROADEX benefits and savings, achieving more with less. To achieve savings in payment management, it recommended, for example, better daily maintenance, for example, drainage maintenance and winter maintenance, a focused rehabilitation designed to find the root causes of problems and to repair the weakest sections first, and to monitor road condition more. And the idea was born to test these ROADEX recommendations, and PEHKO project was born for that in Finland. The PEHKO project was started by the Finnish Transport Agency and ELY centers of Lapland and Central Finland with road scanners in 2015. Then in 2018, the project expanded also close to Helsinki in Hyvinkää area. The very ambitious goal was that in 2025, paved road network would be in better shape and annual calculated paving cost would be 50% lower than at that time. And this calculation was based on ROADEX findings. These are the measures which were decided to be taken. Firstly, maintenance improvement, especially drainage maintenance improvement. Secondly, new technology to enable to focus on the weakest sections by monitoring road network regularly. And thirdly, doing measures proactively before pavement loses the strength and damages are too visible. And this kind of measurements are done for the project. For example, every year GPR, laser scanner, 3D accelerometer, videos, and every 5th year traffic speed deflectometer, or shortly TSD measurements. The screenshot on the right is just an example how all these measurements are looked at in once, which makes it more possible to find the root causes of problems. In this example, the private road junction culvert is locked or missing. Water is staying on the side ditch and absorbed to the road structure, causing deep ruts, shown as black color. Many kinds of statistical analyses are done for the data in the project, and here are two examples of them. In the left side diagram, payment thickness is on the horizontal axis and rut increase rate millimeters per year on the vertical axis. The earlier mentioned so-called pocket money is marked with the dotted horizontal line at 2.4 millimeters per year. From this diagram, it is clear that the thinner the payment, the higher the rut increase rate. And the horizontal strain causes payment fatigue. It seems that if the payment is at least 150 millimeters thick, a rut increase rate is low enough and backlog is incurred only for less than 10% of the network. While under 150 millimeter payments are causing most of the repair debt. This is a major problem in Finland, especially in northern Finland, because payments are too thin on many roads. It is a solution for some sections to make payment thicker. In the right side diagram, PCI or pace curvature index is on the horizontal axis and rut increase rate on the vertical axis. PCI describes pairing capacity of the subgrade. Rutting is of course a bigger problem on weak subgrades where PCI is high. Soft subgrades cause major part of the backlog because road structures are not sufficient for it. The problem is the biggest when PCI value is over 70, when at some sections unbound pace course does not last the load and mode 2 rutting is born. These two diagrams demonstrate the two main problems in Pehko project areas. Here are 7 key reasons for paving backlog in Finland. It is caused by payment structure, blue color, daily maintenance, red color, or both, green color. Problems with heavy trucks on weak subgrade or thin payments has got worse because trucks have become heavier all the time. Also, payment quality is not good enough in some areas. Daily maintenance problems have to do with drainage. Locked or missing culverts at private access road junctions may cause up to 7 millimeters rut increase per year and are a big problem. Also, too shallow or locked side ditches cause problems because road structure stays too wet. In areas with snow, side snow walls should be removed early enough in spring so that water does not infiltrate into the road structure when snow is melting. Due to low financing, we have not been able to repave low volume roads in Finland, but these drainage improvements have slowed down rut increase rates, so it is a proof of their effect and good way to improve conditions of low volume roads. Increasing use of de-icing salt in winter is an emerging problem on thin pavements, especially in Finland. We have noticed a speed up in a rut increase rate because of this de-icing salt. In these diagrams, rut increase rate is on the horizontal axis and distribution of roads on the vertical axis. Different colors in the bars are different road classes and directions. There are vertical lines dividing the rut increase classes into sections depending on how big theoretical cost per meter per year they are causing. The good news is that 40 to 60% of roads are in good enough condition, depending on the road class, of course. They have rut increase under 0.5 millimeter per year, meaning up to 40 years of lifetime. And sections marked by arrows are approximately 10% of the length of the network, and they cause 30 to 40% of annual theoretical cost. So focusing to repair these gives great savings in the long run. Here are 3 tables of the evolution of the payment cost in euros per meter per year. From top to down, Lapland, Central Finland and Uusimaa. Yellow columns show the starting numbers. Uusimaa has, of course, only starting numbers because it started in 2018. The numbers are annual costs calculated from ROAD increase rate. The leftmost column shows the latest cost. Green circles mark the improvement in total in Lapland and Central Finland during the project. The improvement is almost 40% in Central Finland. It means that ROAD increase rate has slowed down in only 4 years, this much. Improvement is almost half of that in Lapland, but still clear improvement. Also in Lapland and especially in Central Finland, cost is already under the pocket money 2.25 euros mentioned earlier. In these diagrams, annual average daily traffic is on the horizontal axis and theoretical calculated annual paving cost on the vertical axis. Left side diagram is cost between 2015 and 2016 and right diagram from 18 to 19 in Central Finland. The colors represent cost per meter per year. Green is the cheapest and black the most expensive. This shows great improvement and it is an evidence that Pehko practices work. Focusing and repairing exact short problematic sections and improving winter and summer drainage maintenance. And as already told, winter maintenance has big impact on annual paving costs. The left side picture shows how water stays in the side ditch because of the private road junction problem. The right side picture shows how water does not have access to the ditch and infiltrates under pavement, causing deformations. Road shoulder verges cause similar problems in places with no snowy winters. These two pictures were taken on the same exact day. Left side was taken outside Pehko area and right side in Pehko area. Geographical location does not explain the difference. These pictures show that the proactive removal of snow walls also has a positive impact on traffic safety. This is a summary of intelligent asset management. Repairing root causes instead of symptoms is often more expensive at that time, but it is cheaper in the long run. Proactive way to work is effective because repairing is cheaper before it is too late. For example, following ROAD increase rate, bearing capacity and payment strain, and to act early enough. Better payment design practices by optimizing measures on exact problem locations, using new structural solutions for roads over weak upgrades, and follow how old repairs perform later to learn from successes and failures. And finally, if you do not remember anything else of this presentation, remember at least that drainage is important. Drainage improvements will pay itself back. So, intelligent asset management provides longer payment lifetimes, which means savings in the long run. Thanks to the good results, Pehko project was recognized with Global Road Achievement Award by the International Road Federation back in 2018. Thank you. I'm happy to answer any questions if you have.
Okay, the audience, do you have any questions? Okay, no questions. I have one question for you. I mean, these kind of big savings only, are you planning in Finland to expand the Pehko policies in other areas?
I haven't heard about any plans, but I think we should do it.
Yeah, you seem to you seem to have quick results anyway, so you have already shown that it seems to work.
Yes, and as you said, the improvements have come very quickly. Like in 4 years, we have got this kind of savings in especially in central Finland.
Yeah, I understand. Yeah. Okay, thank you, Olli. Let's go to the third presentation then. It's from Mr. Mika Pyhähuhta from Laboratorio Uleåborg. He will tell us something about the role of e-learning and social media in rural road asset management. Mika is the founder and creative director in advertising design in the agency Laboratorio Uleåborg. He has more than 20 years of experience working with the field of advertising and a variety of digital productions. He has been involved with all the ROADEX projects since year 2000, and he has participated designing ROADEX marketing and communication materials for dissemination and the e-learning packages. So Mika, the floor is yours.
Thank you, Krister. You can hear and see the presentation probably.
Yep, everything is okay.
Everything is fine. So, regards from Oulu, Finland also, it's nice weather here. So I'm going to talk about a bit of the role of e-learning and social media and rural road asset management. And by starting this thing, I'm going to give a bit of background why this thing is so important in, for example, in learning. So the traditional rural road asset management know-how is slightly disappearing, and people are retiring. Practical father-to-son knowledge will be forgotten eventually if it's not keeping up. The schools are focusing on digitalization, which is of course a good thing, but on the other hand, you still need to keep the roots. And digitalization will change the practices in road asset management. So we need the new knowledge, but as I said, we need to hold on the old one as well. So the information and that data is getting more accurate and real time. The road asset management is changing from reactive to proactive. And the lack of research resources in different countries when current research focuses on main roads instead of low volume roads, for example. And one thing to keep in mind is also that the general trend is that the responsibility of private roads are moving from government to private road owners, and they also need the same information to maintain the good conditions on roads. And on the social media side, bit of a background also for that. So we all know that the world has gone mobile, and all the people have the tools already. And the cars already have and will have even more cameras, GPS and accelerometer roughness measurements, etc. So basically more data will be enabled for various purposes. And everybody can report if it's talking about social media or any app, if it's built on certain purpose. I will show some examples later. And this data will be available for everyone. So basically this brings great potential for rural road asset management to use social media for monitoring the road condition from the user data. Or it can also be used the other way around, that the road owners inform the road users using the social media or apps. It depends how and the way it will be built up, but basically it's the same thing. And on the other hand, this generates a bit of a pressure for the maintenance crews to operate faster, like based on the reaction time and the laws and regulations. And I have some examples here somewhere from Finland. For example, there's a road that is being reported in such a social media channel, as I mentioned, that on the 7th of June, there's a pothole on the road, but it still exists there on the 10th. So 3 days, nothing happened. So this kind of things will get wider. People are more into what they are, if talking about roads, for example, and the certain road sections that they know that it might be problematic in certain time of the year. And also the road owners are interested about getting this information from the users. And another thing, which is not exactly the maintenance part, but I'm just showing this as an example. In Finland, there's a application called Porokello reindeer app, which gives real-time reindeer warnings. So it alerts of high risks for reindeer crashes. So people are having this app on the mobile phone, and when they are driving around in Lapland, for example, and they see some reindeers, and they alert that there are heavy numbers of reindeers, the next car coming will get this alert, and this has been very, very successful. So this kind of a thing probably and most likely will be quite used in the maintenance side as well. Some words about ROADEX social media. This is not about reporting, as I mentioned earlier, but it's about reporting the ROADEX networks information and what's going on in the network, whether it's a results or events where we are going to attend or some other interesting observations worldwide. And we are trying to keep up that as much as possible. It just quite recently started, and we don't have that much followers yet, so please go ahead and start following us too. We go back here, and let's go back to this ROADEX eLearning. So as Ron Munro earlier mentioned, it's been developed, it's an output by the ROADEX projects, and it has been developed by the ROADEX partners, including experience and recommendations gathered by the author during numerous discussions with road administrations and experts in the Northern Periphery area. And these lessons are described with wide range of well-working practices and rule of thumbs. And this e-learning contains 4 different lessons with 6 languages: permanent deformation, roads on beat, drainage of low volume roads, environmental consideration of roads. And these all of these lessons are based on the information gathered by the ROADEX and the ROADEX group. And it's about practical informations, lots of links to reports we've been developing over these years. There's a lot of information in video format, photographs, diagrams, another demonstrations I will show you later, a few of them. And in the end of each lesson, there will be a test. So you can basically see whether you learned the thing or not, at least the basics. And we try to keep that up as much as possible. And the plan is that the last version, which is permanent deformation, will be updated by the end of this or the next month, if I'm correct. So here's one example what kind of things you might find in there. So this is a point cloud data, and as Olli and Ron earlier mentioned, that ROADEX has proved that drainage is a very essential part of the road asset management, and this is one modern method to monitor the road and ditch conditions, for example. And on the next one, there is a demonstration about stresses and strains on road structure as the most critical position for development of permanent deformation. So the colors I will show soon will indicate the risk of permanent deformation or failure in the road layer. Black meaning fail, as you can see here in the middle, and the green you will see later, that's more or less on the safe side. So in the starting point, you can see we are having super single tires with pressure of 800, 5 centimeter payment layer with 1500 MPAs, 4 centimeter of structure with 100 MPAs, and 5 MPAs upgrade. And now, as we see, if this is a starting point, it's already failing. And basically what you can do is to compare by duplicating the current situation and then moving and trying to test what might fit or change these things. Let's say we add some thickness for the pavement, and well, we see that we are already on the safe side. So this is just one example, and I recommend it. You can go and look for yourself. There are a lot of interesting stuff in there. So, and how do you end up there? Of course, you go to the roadex.org website first, and on the right-hand side corner, you find this green menu where you find e-learning. By choosing the e-learning, you get the selection of languages. If you pick English, you get the lessons, and eventually you end up to the lesson you choose. And when you are in there, you go back again to the right-hand corner where you can navigate through the whole lesson or the next one and next one and next one. So it's very, very simple. And this is built on the website and should be also, it is mobile friendly if you are into more phones or tablets. And as I said, we are not alone. This is the statistics from Google Analytics from the past 3 years. So we have pretty much conquered the whole world. So there's been more than 300,000 users for the ROADEX e-learning. And average time on the page has been roughly 3 minutes. And of those 300,000, 190,000 has been spending nearly 5 minutes there. So it's really, really used piece of information. And there's a bit of more statistics about content drill down. As you can see from here, the drainage is the most interesting topic it has been the past 3 years actually. Environmental considerations coming next, and then there's permanent deformation and erosion peat. So based on this information, I think we are going to the right direction with the content provided in there, and hopefully we'll keep up putting some new stuff whenever it's possible. So the world is changing and we need to keep up and adapt, but not forget the good things about the past. So ROADEX e-learning, social media and apps will support you on the way there. Thank you. If you have any questions, please feel free to ask.
Okay, anyone from the audience? Some questions? No? Okay, Mika, I have one question for you. I mean, like this, we have this coronavirus today that has led to distance learning, like in schools in all levels in the world and other things also. In that context, how do you see the development of such tools as e-learning in the future, or other useful media?
Well, I think people are kind of self-educated in a way that they want to even duct the information by themselves, and these kind of tools, whether they are e-learning or some other new type of things that are coming, they will be probably more and more successful in that way. And I think it should go that way as well. So it, on the other hand, it teaches people to duck up the information by themselves, but at the same time, it kind of keeps the information up, which is the most important thing. That it's not that much about the technology which are used to find the information or teach to use that, but it's the information itself that is important.
Mm-hmm. Okay. Thank you, Mika.
Thank you.
Okay, let's move let's move on to the next presentation, and the fourth one. It's Mrs. Annele Matintupa from Finland. She will tell us more about new road survey technologies in rural road asset management. And Anneli has a Master of Science in Civil Engineering and is working for road scanners. She has specialized in ground penetrating radar, interpretation and analysis, road analysis, and road rehabilitation designing. She's been involved in ROADEX projects, mainly road drainage analysis, survey methods, and different rehabilitation quest solutions. So, Anneli, please start.
Thank you, and good afternoon from Tampere, from south part of Finland. My topic today is new road survey technologies in rural road asset management. At first, I will tell you about intelligent asset management, then modern road survey technologies and how these can be utilized in road analysis and rehabilitation design. So what is intelligent asset management? The traditional way to take care of road condition is as reactive, where the measures are taken based mainly on the surface condition monitoring results, which in practice means the observation of visible damages on the road surface. The proactive way is to monitor and detect the root causes of the surface condition problems. Then the operations can be performed before the damages appear. Here in the photo on left side, you can see some damages. In reactive case, only the new pavement would be spread on the top of the road surface. In the picture on the right side can be detected that the ruts are quite deep and they are localized around the private access road. So the main reason for damages is clogged culvert, which prevents the water flow and directs the water directly to road structure and road surface. The repaving is not a lasting solution and the damages will appear soon back. The right way to fix this is to improve and clean the culvert or change it if needed. Modern road survey technologies are usually understood as non-destructive survey methods. For example, ground penetrating radar, laser scanners, accelerometer together, digital video cameras and GPS provides good information of road structure. Bearing capacity can be measured with falling weight deflectometer or with traffic speed deflectometer. Ground penetrating radar is a geophysical survey method which is based on technique where the transmitter antenna sends a pulse to the road structure. Part of the pulse reflects back when the properties of the material change. The receiver antenna registers the time and amplitude of the pulse which is reflecting back. The GPR data can be handled and analyzed with several methods, and many different parameters can be get as output. For example, layer thicknesses like pavement, pace course, and the total thickness of road structure. Also asphalt airways content, moisture, frost and ice lens detections. Also different cracking and delamination can be localized. Laser scanning is a technique where the distance measurement is calculated from the travel time of laser beam from the laser scanner to the target and back. When the laser beam angle is known and beams are sent out in different directions from a moving vehicle with a known position, it is possible to make a 3D surface image or point cloud from the road and its surroundings. In the point cloud with millions of points, every point has an X, Y, and Z coordinate and a number of reflection or emission characteristics. Laser scanner measures 100 profiles per second. That means depending of the driving speed, cross section as from 5 to 20 centimeters. The density of points is the most dense on road surface and changes as sparser on outside of the road area. From the laser scanner data can be calculated many parameters as rut depths, cracking, patches, ditch slopes, verges, and so on. And here is an example how laser scanner data can be achieved in road condition analysis. Laser scanner measurements has been performed on years 2015 and 2016. Rut depths have been calculated from data of both years. As reducing these values, the rutting increase will be got as a result. Here you can see a place where rutting increase is more than 7 millimeters per year. Observing the road area as whole can be seen that the reason for this is private road access and its poor performing or totally missing culvert. This should be fixed before it causes more expensive and serious problems. Accelerometer is a device that measures acceleration forces. The position, acceleration, and angular velocity are measured to different directions, back and forward, sideways, and up and down. Acceleration is the second derivative of position. When a car drives over a road with roughness, the roughness produces accelerations to the car tire. Bigger amplitude and shorter wavelength of the roughness produces larger acceleration. In other words, severe road damage produces large acceleration. Together with GPS positioning system, the measured accelerations can be positioned on the road. The accelerations also depend on the driving speed. So a constant driving speed over the whole section is desirable. Accelerometer measurements are working well also on gravel and forest roads. So accelerometer data can be used also in regular to follow how roughness will develop. Here is an example from northern Finland where test route has been measured several times during the winter and springtime. On some sections arises the spring thaw weakening symptoms. Roughness turns to be more severe when springtime is going on. These measurements were also possible to follow online in internet during the measurements. Traffic speed deflectometer and falling weight deflectometer are used to evaluate bearing capacity and to it related parameters. Traffic speed deflectometer measures with lasers the time of creation speed of surface deflection. Based on that can be calculated the value of deflection. The results can be utilized as same way than more traditional falling weight deflectometer results. The falling weight deflectometer device consists of a weight that drops from a pre-specified height on the plate that is supported by rubber dampers that rest on a road-based circular plate with specific diameter. The drop of the weight is designed to simulate the load produced by a passing heavy vehicle. The load applied to the road can vary from 20 to 150 kilonewtons, although the most common load is 50 kilonewtons on 300 millimeters loading plate. The deflection is measured by multiple geophones placed radially starting from the center of the load plate. From the data can be analyzed and calculate different parameters like SCI, surface curvature index, BCI, base curvature index, and pavement strain. With the falling weight deflectometer or traffic speed deflectometer values and layer thicknesses interpreted from GPR data, the substructure and subgrade module values can be calculated. The SCI is calculated by subtracting the D200 deflection value, or in some countries the D300, from the D0 deflection value. It can be very useful in determining if a road has mode 1 rutting problems. This gives an indication of the stiffness of the pavement and the top part of the unbound base course. A high SCI value indicates a risk for mode 1 rutting. The BCI value is calculated by subtracting the D900 deflection value from D1200 value, and it's an excellent indicator of how road structure can spread a wheel load over a weak subgrade in order to reduce the vertical stress at road structure subgrade soil interface. If the BCI value is high, this indicates either mode 2 rutting or pumping problems. A strain value is calculated based on GPR and polling weight deflectometer or traffic speed deflectometer data. It indicates the fatigue damage risk of pavement. On this example comes out few sections where can be seen damages. Also BCI values are quite high, and also strain values at the same place where rut depths are quite deep. Also the total thickness of road structure is thinner on this section. As analysis of all data can be said that the main reason for the damages are again private access road and its missing or poor culvert. So, how we can summarize the benefits of new modern survey techniques? The development of these techniques has been very rapid in past few years. Nowadays, it is easy to observe a lot of data and different parameters together, not only of road surface, but also from its surroundings. The TSD method provides continuous information on bearing capacity with a high-speed survey. On local roads, where the changes in bearing capacity are sudden and local, the dense testing interval is very important. Note that on the smallest roads, this method cannot be used because truck needs enough space. With the combination of modern data collection methods and joint analysis of the results, the diagnostic capabilities for road problems reach new levels. There are many possibilities to develop automatic diagnostic methods. The actual reason behind a road anomalous behavior can be found, and evaluations of life cycles can be done. This makes proactive maintenance possible, and great savings in road life cycle cost can be achieved. And thank you all for listening my presentation.
Thank you, Anneli. Any questions from the audience? No. Okay. Anneli, you have mentioned like digitalization and new techniques, they are expanding rapidly. And as we have seen here, I mean, you showed some powerful tools in road management. What do you think about the future? How will it be? Can you see where the fastest development is? Or where will it be in 5 to 10 years' time? Do you have any opinion?
I think the methods will be more exact, maybe also easier to understand and internalize. We can see beyond the surface all structures, and in the future also 3D models are quite common. And I think we can also analyze and recognize material properties better. And maybe also the time slices are important. And based on this, I think this proactive maintenance is more possible in the future.
Okay. Thank you, Anneli. Okay, everyone, let's move on to the final presentation. And it's Mr. Goran Mladenovic from University of Belgrade, Serbia. He will talk about challenges and solutions with rural road asset management in Southeastern Europe. Goran is a professor of payment engineering in Faculty of Civil Engineering, where he also leads the Laboratory for Payment Research. He has over 30 years of professional experience and has been involved in many national and international projects dealing with design, rehabilitation, maintenance management, and structural evaluation of road and airport payments, paving materials, and asphalt technology. He has also been involved in several European research projects related primarily to road asset management and financing in road infrastructure. So, Goran Mladenovic, welcome. The floor is yours. Something went wrong there, or? Timo or Anneli, did you get some kind of message or anything? Hello?
No, I have not heard anything from Göran.
Yeah.
But
I think he seems to be connected anyway. I don't know that. If I look at the participants. No, there's no, can't hear Goran at all. Goran, can you hear us? No, nothing. Okay, I suggest then we take a 3 minutes break. So come back in 3 minutes and maybe get some coffee or something. We'll wait until Goran maybe can connect.
Göran, I'm here now sharing your presentation, but we cannot hear you.
Yeah, maybe, do you have your microphone on, Goran? Or is there something else that is wrong? I don't see any kind of microphone sign either at your.
That is the problem. So. Okay, he's leaving, so probably coming back very soon again. So then
Okay. Yeah, we'll wait a couple of minutes. Let's see. Yeah. Yeah, he has reconnected, so I don't know. That's a pity. Okay. Yeah. Yeah, he's trying to reconnect, but nothing seems to work. I don't know. I can't hear him anyway, so nobody else, of course. Anneli, are you showing this presentation? No.
Yes, I am sharing it from here.
Okay. Yeah. Mhm.
I guess the problem is now the audio. We cannot hear the audio, so probably cannot. But let's wait a couple of minutes if it's okay for Krister, and then we'll just go to wrap up the final discussion.
Yeah. Yeah.
Some other time.
Yeah. Did Goran try to? Was he connected before the meeting, or did it work then?
Yeah, he was, and we were discussing, so something went.
Okay.
Okay, now.
Yeah.
If I can tell about this webinar, so ROADEX in general has now, Timo Saarenkiito is now speaking here. ROADEX webinars are being arranged so far at least 2 times per year, one in spring and one in the fall, but the plan is in the future to like have them more, and we probably have like a two webinars per season. There are a lot of interesting subjects that we are planning to do. Also, one issue about the e-learnings that we have, we will arrange seminars related to each e-learning and presenting a little bit about what's new in each e-learning. So it's much easier than to see the packages, and will inform about these on the ROADEX websites and internal messages.
Yeah. Okay.
Okay. And I guess if we cannot get Goran now to present it, so in one next webinars that we are arranging, Goran can, with the better luck with the connection, Goran can make this presentation, because in general it is very interesting. We've been working quite much on Balkan areas, and I know from the experience that there are a lot of similar issues on low volume road condition management, but then also some other challenges that are have to tackle slightly with the different policies than we are doing in the north. Okay, Goran.
Timo,
All right.
do you hear me?
Yes.
Yeah.
Yes.
Yes.
Please go ahead. You just Goran. You
Welcome,
just said,
Goran.
yeah. Good.
Yeah.
So.
I made
okay.
a presentation of you before,
Yes.
I've heard. Thank you very much.
Okay. Okay. Just go ahead.
Thank you very much. I'm really sorry for these troubles. You know, at the beginning, everything seemed to work well, but there were problems with Teams. Thank you for invitation to share with you some experiences with implementation of road asset management systems in our region in Southeast Europe. And I'll just briefly introduce you to the region and what are the specificities of road networks that are being managed by these agencies. And then I'll talk about some of the challenges. As Timo said, most of the issues that you are covering under ROADEX network are common to our region, and there are many similarities and many experiences that probably can be shared and used in these countries. This is basically the least developed region, Europe. I mean, it's usually called the Western Balkans. It consists of 4 former Yugoslav republics: Bosnia and Herzegovina, Serbia, Montenegro, and Northern Macedonia, as well as Albania. And it's surrounded by EU member states. Some of them were recent members of EU. But then when you look at GDP per capita, it is below half of EU average. So really the least developed part of Europe.
Goran,
yes?
One question. Have you changed are you a picture 3 or something now? You haven't changed you have gone through the outline and you are like a general overview of the region. Have you changed the picture on your computer? Because we can't see that.
It's still slide number 1 over there, but can Annele show the slides and you just announce, okay, now we are.
Now it's okay, yeah.
Now fine, yes.
Okay, I'm sorry, I was changing these slides, but I'll use this mode now.
Okay.
Because, I mean, this was the previous slide about location of the region and, you know, basic information about GDP in the region. And then when we talk about road network and road density, you can see that there are some countries that have relatively decent road density compared to EU average. But then, for example, Albania or Kosovo have substantially lower density of road network. And also when we compare to population, really small density of the network. All of these are transition economies, so motorization level is growing. I mean, people are still buying cars here, you know, and still, I mean, we are lagging behind the EU average. As you can see, I mean, in Montenegro, there the average is about 300 something vehicles per 1,000 inhabitants. In all other countries, the motorization rate is lower. But in recent years, in the region, there was trend to build motorways, basically. So motorway network was expanding quite fast in some of these countries. For example, in Serbia, in recent years, in Kosovo, in Albania also, although Eurostat doesn't show it, but basically there are about 330 kilometers of motorway network that has been completed in recent years. So these countries are trying basically to improve the network, but the issue is that many of these projects are not well prepared the traffic level is relatively low, and on most of these motorway sections, traffic level is below 10,000 vehicles per day. So that can hardly justify the motorway standard that has been implemented on one side, and then on the other side, the income or the revenues from these motorways cannot pay back even for maintenance of these motorways. So that's one of the problems in the region. On the other side, when we talk about transport infrastructure, still a majority of investments are related to road infrastructure. In recent years, there were some attempts to improve railway infrastructure that is also in relatively poor condition. In some of the countries, as you can see on the right chart, the majority of transport is being done by road network. So that is why road networks are still very important, and on the other side, they are deteriorating as a result of this freight transport that is using it. As I said before, the focus is on building new sections, and unfortunately, maintenance is the second place. As you can see, in most of these countries, majority of investment that sometimes ranges up to 2% of GDP is basically for building new road stations because of this relatively limited road density. And then there is no money for maintaining existing networks, which then causes rapid deterioration of the network. And then all the things that we have already talked about, instead of proactive maintenance, we are in reality doing reactive maintenance when there is money for this reactive maintenance. These new projects are mainly financed by international financing institutions. There are some EU grants for some sections, but some portion of these works are financed by from budget. But as you can see, involvement of private funds is still very limited. In the region, basically, there were some successful projects in airports, but not yet in road network. In Croatia, there were a few road concessions that were, let's say, quite successful, but in these countries, there were no similar projects. Several administrations, road administrations in the region tried to implement road asset management systems in the past, but typically with limited success. These efforts included development of database, comprehensive survey of networks, but then there was no continuity, and basically that was limited with lack of capacity and lack of management commitment. This is my opinion, but the issue was that network level analysis performed typically sporadically, and primary motivation was to get new loan from international financial institutions for new sections, but basically maintenance of the existing network suffered a lot. Some of the agencies procured some of this survey equipment. I mean, not sophisticated as Anna mentioned in the previous presentation, but actually these are or this, but there is no strategic approach if these agencies are going conditions with in-house, or they are going to outsource this service. The issue is also there is lack of capacity. They don't perform calibration of this equipment as needed. sometimes the results of these condition surveys are really questionable. Regarding decision tools that were used, I mean, as most of these projects or these implementations were initiated by the banks, especially World Bank, you know, they forced or they insisted to use HD4 as decision tool, at least for the beginning. But then there were some other tools that were also used in past projects or projects that are ongoing. As I said, there are many common problems that were also identified in the ROADEX network that are also very relevant in our region. But also we have, for example, one problems that is related to road safety. As you can see, the number of accidents, number of fatalities is still probably the highest in the Europe, substantially higher than average EU. And despite all these efforts to reduce number of accidents, improve safety, still the rates are really high. The other issue that is important is climate change adaptation that was also mentioned in one of previous presentations. And it is also a problem for road networks in the region. We had serious flooding, for example, in 2014, with huge amount of precipitations that also triggered a lot of landslides. So these are some images from that situation. There were some earthquakes because this is a zone of earthquakes, especially close to Adriatic Sea, and this road is from Montenegro. That's one quite important road connecting two cities in Montenegro that got destroyed during this. So, as team, we work together on some of these projects in the region in Macedonia. I think we did one successful implementation of road asset management system that included the GPR measurements, that included axle weight surveys, which were important because there were a lot of overloads in the region, in the country, that is causing also deterioration. Also, there was successful implementation system in Albania, and now this project in Serbia includes comprehensive roads condition survey and development of that database. But I think it's fifth time in recent 20 years that road administration is doing survey and developing database. My problem is that this information is not in reality used in everyday management of road network. Project just started in Bosnia. In Bosnia, the situation is very specific because they have 4 road agencies, because they have 2 entities. So it's quite complicated situation, but one of these agencies just started the implementation of the project, and other agencies are also pressed by the banks to implement road asset management. As I said, the improvement of road safety is still one main focus, and the World Bank also supported several studies on climate resilient roads and infrastructure adaptation in Albania, Northern Macedonia, Serbia. So these are efforts that are ongoing now, and I just can say that learning about ROADEX, I mean, basically, it seems to me that it will be possible to do some similar approach in the region to enhance cooperation between these road administrations, and also maybe to enhance cooperation with ROADEX as well. Thank you. And sorry for that's at the beginning.
Thank you, Goran. Thank you. Any questions to Goran? question. Silent audience. Okay, I have one question for you. If you compare Northern Europe to Southeastern Europe, both in road management and in international cooperation, do you see any big differences?
Well, there are some differences. I mean, primarily related to climate, because you know, for example, you have severe winters there. You use static tires, so rutting is main distress that is observed there. On the other side, in Southeast Europe, we have hot summers with high temperatures. You know, pavement temperature sometimes becomes higher than 60 degrees. So we have rutting caused by by high temperatures, and it's important to select appropriate binder for these roads. On the other side, there is similarity, for example, regarding traffic level, because many roads in Northern Europe, you also have a relatively low traffic that is similar. Southeast Europe, the reasons are different, because population density in your region is lower, and here, the level of development is lower. So, but the outcome is similar. You know, we don't have a lot of traffic, many of these roads. And then major difference is basically capacity of the administrations and resources that are available for maintenance.
Yeah, thank you.
You're welcome.
Okay, everyone, that was the last presentation today at this webinar, and I want to thank all of you, all the presenters, very good presentations, and we finally got your presentation also, Goran. It was a little bit problems there, but it worked out finally. So we have had a lot of new information and progress in different ways and in different areas. We heard about new techniques and digitalization. They're increasing and evolving, and it moves very fast. As Ron mentioned in the beginning, that we have decreasing funding for the roads, and that's something that we all are facing right now. I've been talking to other road administrations in Europe also, and they are having the same problems. So we need to do things smarter, and that's maybe like the PECO project is one of them. To save money, do more for less. And of course, you use new techniques more. So that's a little bit of a short summary. Any questions from the audience at this moment? No, nothing. Okay. As Timo mentioned while we were waiting for you, Goran, is that we will have some more ROADEX webinars in the future. We are aiming at having 4 webinars per year, so there will be more to come, and I hope you will all be interested. And I thank you, the audience, also for connecting, and well, thank you all for this. That's my final words. We are just on schedule, so we have 2 more minutes. Any other comments from the speakers? Anybody else?
No, on my behalf and on ROADEX Secretariat behalf also, thanks, excellent presentation, and we stayed in time schedule, so well prepared, well taken session. So thanks for everyone, and have a nice Juhannus, which is we are facing now midsummer festivities. So and so enjoy your weekend.
Yeah, that's right. Thank you, Tim.
Thank you.
Thanks.
Thank you. Bye.
Okay. Thank you all.
Bye-bye.
Bye.
Bye-bye.
Thank you.
Bye.